A chess competition consists of two teams, each with 6 players. At the end, each player gives high fives to all their teammates as well as each of their competitors. After all of the high fiving is finished, how many high fives have occurred? All right, those rowdy chess players running around, high fiving each other. Now, how many people are there? Well, there's 2 teams, 6 on each team. So we have a total of n equals 12 players. And they're going to high five their teammates as well as the competitors. And if you think about that, let's say I'm one of those players. I have 5 people on my team. I need to high five and the other 6. So that would be 11 people I need to high five. So from my point of view, I have 12 times 11 to make. Now, you are on my team too, and you high five me. Well, what's the difference between you high fiving me and me high fiving you? Right? We're high fiving each other. So from your point of view, we are double counting. So we should divide this by 2. Now, it turns out this is a combination. We are, out of the 12 people, selecting people 2 at a time where order doesn't matter, right? You high-fiving me is the same as me high-fiving you. So this should also be a combination. So I should be able to also write this as 12 choose 2. Let's check it out on a calculator. All right, first glance at this problem is a fraction where I have 12, not 21, 12 times 11 things to do, but that double counts you and me. So I have to divide that by 2. So there's 66 high fives that ought to happen from that perspective. This should also be a combination. So if I whip out the combination calculator, I have 12 individuals. I want to select 2 at a time, and order does not matter. And I can see I get the same 66 there. And just for fun, let's look at the factorial version. Remember, a combination, n choose, what does Desmos like to call that letter? He likes to call it R. Sometimes they call it K. That's always going to be n factorial divided by n, there we go, minus r factorial. Now that's a combination where order does matter, but dropping in that division by r factorial takes out any replicated counting. So that turns permutation into a combination. For our version, we have 12 factorial. 12 minus 2 would be 10 factorial. And then times 2 factorial. Let's think about that. 12 factorial is 12 times 11 times 10, all the way down to 2 times 1. And then down here on the bottom, we also have a 10 factorial, which is 10 times 9, blah, 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 all the way down to 2 times 1. And we also have that multiple of 2 factorial down there, which is just 2 times 1, or 2. And the beautiful thing about these combination permutation factorials is a bunch of stuff cancels, leaving just the 12 times 11 divided by 2, which is the other way I thought about this problem. So counting is hard. Does order matter? Does it not matter? Sometimes. Here it does not. Thanks for playing.